Hello everyone, today I'm going to show you how to derive nth order derivatives in Sine ax function. In order to get nth order derivative formula or general form for Sine ax function, at first we should do some derivatives in order to get some trend. The first order derivative in Sine ax equals a cosine ax, and the second derivative in Sine ax equals the derivative in the first order derivative function. So we have the second order derivative in Sine ax equals minus a squared times Sine ax. We can keep on going to get the eighth order derivative, which is the derivative in seventh order derivative functions. So we have eighth order derivative in Sine ax equals a power of 8 times Sine ax. From these 8 terms, we should get some trend. As you can see, for odd number derivative such as 1, 3, 5, and 7, all these 4 derivatives include cosine ax, and the only difference is plus and minus sign. However, maybe you can realize that the cosine 0 is 1 and the cosine pi equals minus 1. So the cosine 0 and the cosine pi may be related to the sign change. So we can make a reasonable assumption that for the odd number n, the nth order derivative in Sine ax equals minus a power of n times cosine ax times cosine n plus 1 pi divided by 2. We can verify this assumption by using our previously determined 4 derivatives, such as the first order derivative in Sine ax. We have a cosine ax. So we can put n equals 1 in this assumption, which we can get minus a times cosine ax times cosine 1 plus 1 pi divided by 2, which equals minus 1, combined with this minus. So we can get a times cosine ax, which is exactly the same as here. Similarly, we can verify this assumption by using the rest 3 terms. Obviously, this assumption is right. Similarly, for the even number, we can do the same job. Let's go back to the previous page. As you can see, for the even number such as 2, 4, 6, and 8, all terms include Sine ax, and the only difference is minus and positive signs. In this case, we should realize that Sine 3 pi divided by 2 equals minus 1, and Sine pi divided by 2 equals 1. So we can make a reasonable assumption that for the even number n, the nth order derivative in Sine ax equals a power of n times Sine ax times Sine n plus 1 pi divided by 2. Similarly, we can use our previously determined derivatives to verify this assumption. Obviously, this assumption is right for the even number. However, we can put the odd number derivative and the even number derivative together, because when the n is odd number, the even number derivative becomes 0, because n plus 1 becomes even number when n is odd. So Sine n plus 1 pi divided by 2 will be 0. Similarly, for the even number n, the order derivatives becomes 0. So we can have nth order derivative form or general formula for sine ax function, which is minus a power of n times cosine ax times cosine n plus 1 pi divided by 2 plus a power of n times sine ax times sine n plus 1 pi divided by 2. By using trigonometric formulas, we can put these two terms together, which is minus a power of n times cosine ax plus n plus 1 pi divided by 2, which can be written as minus a power of n times sine pi divided by 2 minus parenthesis ax plus n plus 1 pi divided by 2. And finally, we can get nth order derivative in sine ax function equals a power of n times sine ax plus n pi divided by 2. However, I should emphasize that this nth order derivative formula is obtained based on limited terms of derivatives. So we have to prove it mathematically for the general case. I will talk about it in our next video. I hope you enjoyed this video. Thank you for watching.